Good morning and welcome to this REPower webinar, DHC Market Outlook 2025, the heat transition in action. I am Pauline Lucas, Policy Director at REPower, and today I have the pleasure to welcome my colleagues and members. Our very own Eloi Perle, Market Intelligence Director at REPower, who is spearheading the publication of our yearly DHC Market Outlook. Lorraine de Houton, Business Development Executive at ENGIE, a global group active in low carbon engine services, operating over 50 networks in France and more than 300 globally. Olaf Lidviakov, Senior Manager for European Heat Policies and Regulation at Berliner Energie and Wärme, the local utility supplying Berliners with heating, cooling, and electricity. And last but not least, Emanuele Pingaro, Heat Electrification Sales Manager at Turboden, an Italian firm and a global leader in the design, manufacture, and maintenance of organic ranking cycle systems and large heat pumps. So today, with our speakers, we will dive into insights on the development of DHC networks in Europe from our flagship publication, but also from our speakers. We will highlight the current market momentum, so where district heating and cooling is, where it expands fast and why. How are our speakers, organization and companies meeting the various challenges, so addressing growing demand while decarbonizing. And we will also pinpoint bottleneck and look into solutions. And last but not least, we will also outline some policy recommendation to support the DHC sector. A brief note on housekeeping. So the webinar will be or is recorded and available on YouTube today. You will receive the slides by email tomorrow. And there will be some times after the panel discussion for some questions. So please use the Q&A box to ask our speakers your questions. I will now leave the floor to Eloi for the first presentation.
Thank you very much, Pauline, for your kind words. So I will now present our latest data recently launched at the Congress in Prague. So you can find the report on our website, and you can also find all the country chapters on the website. They are available for our members, but also for policymakers. Before I start, I would like to thank again our sponsors. So it's BAV, NG, and Turboden, and also our friends from Kamstrup, who could not be with us today. So Kamstrup provides smart metering systems to operate district heating and cooling networks in the most efficient way, and they also kindly sponsored the report. So the latest data I will present is for year 2023. It was still a difficult context for energy in terms of supply, in terms of prices, but in this context, actually, our sector proved its resilience by growing and by adopting new fuels. And I will start with the mix of sources used in district heating at European level, what you can see on the slide. And even on a yearly basis, there are very interesting changes in the energy sources we use. So in 2023, we saw a decrease in the overall share of fossil fuels used in district heating systems. So to be more specific, a decrease of respectively 12 and 3% for coal and natural gas, and other alternative sources are stepping up. In total, in 2023, the share of renewable and waste heat represented 44.1% of the fuel mix, or an increase over a year of 9.2%. If I go fuel by fuel, bioenergy went up from 32 to 34%. The rise is mostly explained with an increase of bioenergy in the fuel mix in Poland, reflecting measures to cut coal and reduce emissions. But I think the very interesting thing is the booming production from new sources. The share of large heat pumps went up by 44%, representing in 2023 6,500 gigawatt hour of production. So if 10 years ago, nearly all capacity was based in Sweden. We see these days large heat pumps projects popping up everywhere across Europe, from Brescia to Mannheim, Cologne up to Oslo. The share of e-boilers went up 80%, so today they make 1%, but it will grow, and the growth is particularly visible in Nordic countries, with an increase in the share in the total supply more than doubling in 2023 for Denmark, Finland, Sweden, and Norway. And this evolution is driven by regulatory conditions and also low prices for electricity on these markets. Across Europe, the rise of large heat pumps and e-boilers will serve a dual purpose: to decarbonize the heat market, but also in the broader picture to stabilize grids and support the integration of renewable electricity. As you know very well, electricity is easily transmitted but costly to store, while heating and cooling are local and can be stored efficiently. And today, our sector is very well positioned actually to capitalize on these synergies. So, well, if I continue fuel by fuel, waste heat goes up by 20%, representing 4.1% of the mix. Geothermal, you can see, provide 2% of the total supply, up by 5%, with two-thirds supplied in two countries, in France and Iceland. And actually, on geothermal, we see the need for de-risking measures, but also, simplification of access to underground in some countries to accelerate the deployment and meet the potential. We see a contribution from solar thermal that remains unchanged, in spite of the potential in cities and communities where solar can help substitute fossil fuels, but also, support a better use of existing capacity in summertime. I think what is really, really interesting is when you consider the big picture on a 5-year perspective, and here the changes in the fuel mix appear very clearly. For European district heating, the share of renewable and waste heat went up by +9 percentage points within the last 5 years. And we see some sectors decarbonizing very fast in some countries. In Finland, for instance, we saw over the last 5 years an additional share of renewable and waste heat sources of 20 percentage points. After the fuel mix, I would like to turn to capacity and network. So in 2023, we delivered nearly 500 terawatt-hour of heat. Sales were down 3% in major markets. So this was largely due to a warmer weather, to energy conservation efforts, and energy efficiency measures. But despite these headwinds, actually, our sector has continued to outperform expectations by expanding its customer base. And I think this is the very important point. You can see on the slide that district heating represents nearly 200 kilometers of pipes, up by 1.8% on a year, or an additional 3,000 kilometers of pipes. So it's like adding in a year the networks of Berlin and Vienna, to give you the scale. And on a 5-year perspective, we count an additional 15,000 kilometers on large markets. And this growth is mainly driven by Germany and France. But it's also interesting to see that also on markets where our sector is quite mature, we see some growth, with 3,000 kilometers added in Denmark and 1,000 kilometers added in Finland within the last 5 years. Now, considering the outlook 2030 and 2040, well, how does the future look like? Well, we have a first indication in the data for the year 2023 of where the sector is heading to. But we also have precious data in our country chapters with decarbonization roadmaps provided by members. And there are obviously common trends and regulatory opportunities shaping investments. So I will illustrate quickly with three countries where our sector stands at different stages in terms of fuel mix and market share. You can see on the slide Denmark, Germany, and Czech Republic. So we see in the roadmap of these three countries an expansion of the customer base and a shift from fossil fuels to alternative sources. In particular, in Germany, where there is high potential, the market share of district heating should double by 2045, according to the Prognos study. And this is represented by a higher level of production. You can see on the slide from 120 to 180 terawatt hour in 2045. In the Czech Republic, as a result of energy efficiency measures, the expected output is decreasing in spite of incremental growth and the connection of an additional 40,000 flats by 2030. But also in the Czech Republic, we see a clear shift of sources driven by the coal phase out by 2030 and the gradual introduction of new sources. In all scenario, you can see the share of large heat pumps using ambient heat is really increasing. This is the pink share on the slide, but you can also see increasing shares of geothermal and new urban and industry sources going up. I mean, the share of deep geothermal goes up in particular in Germany and the Czech Republic. And the share of waste heat also expands, ranging from high temperature industry waste heat to also waste heat from power production. It is also interesting to see how the share of bioenergy evolves in this scenario. You can see that it is increasing for both Germany and Czech Republic by 2030, but it decreases in the long run. Whereas in Denmark, where bioenergy is already well represented, actually the share already decreases by 15% in the mix by 2030. When looking ahead to 2030 and 2040, it's also important to see how actually the customer base for this heating is expected to grow. So to assess this, we have reviewed available data and compared stated objectives with the actual developments on the ground. I think one thing is clear. The recent energy crisis has prompted very positive actions from several governments across Europe, sparking new momentum on some markets. Our analysis showed that by 2030, more than 8.5 million households should be connected to district heating networks in selected countries. However, it is also true that when examining the pace of development, especially in large markets, where it becomes apparent that there is a gap between policy targets and the current business as usual trajectory. So we identified a gap of around 25% and 28% for large markets such as Germany and France, respectively. And analysis from our contributors highlighted key barriers to investment at national level. So to attract investors, we really need measures to de-risk projects, faster access to state aid, and also some more specific measures like flexible electricity tariffs to support the deployment of large-scale heat pumps in some countries, or, as I mentioned earlier, some specific measures to de-risk geothermal projects. But I'm sure our panelists will also elaborate on these points. I would like to talk now about district cooling. Sales represented over 3 terawatt hour in 2023. And I think what is important to consider sales, we should also look at the expansion of the cooling infrastructure. You know, district cooling is becoming increasingly relevant these days as electrification accelerates across sectors, and district cooling can provide an efficient cooling supply based on free cooling, on waste heat, on waste cold. And doing so, district cooling also helps manage the capacity and free up electrical capacity for other purposes. And I can give one example of a very large district cooling system in Stockholm, compared to a scenario where cooling would be delivered by split solutions, by um, individual options. The cooling systems in Stockholm enables to cut electricity consumption by 60%, which means that it frees up capacity for other purposes. So it also means actually that the growth of district cooling will also depend on how well we can monetize this competitive advantage of offering flexibility to the grid. In terms of infrastructure, we count 1,300 kilometers of distribution lines. And within the last 5 years, discreetly but surely, the infrastructure has very well developed. So networks have expanded by 20% on the five largest markets. You can see the graph. In terms of outlook, we count on an additional 2 terawatt hour by 2030, with additional production stemming mainly from France, from Austria, from the Nordics, but we are also aware of very good developments in other countries. I'm thinking in particular of Spain. There are big developments in Catalonia and more precisely in Barcelona. Now, to realize the potential and serve the current wave of booming demands for cooling, we obviously need better collection of data at national, at EU levels. We need cooling roadmaps by cities, a level playing field, and I also think we need some de-risking measures on some market. And from here, I will close with a quick summary of our Market Outlook 2025. Please go on our website, download the report, and I'll give the floor back to Pauline for the panel discussion. Thank you.
Thanks a lot, Eloi. I think we see that they're very interesting developments, and you outlined the major trends for the sector. So I see growth with expansion of the customer base. I see decarbonization. I see diversification. So let's dive into those trends and see how it's also reflected on different markets. I will first turn to Lorraine. So Eloi has shown the developments on the European markets. Can you tell us a little bit more, as ENGIE is one of the leading operators on the French market, what are the developments in France, and what do you see as the main trends?
Yes, as you have said, currently France faces a strong DHC momentum. In 10 years, you can see that we have increased the number of district heating from 500 in 2013 up to 1,000 in 2023. And in parallel of this development, district heating have been decarbonized from 31% renewable and waste heat share, you can see below, up to 66% today, and with the intentions to increase up to 75% in 2030. And this development remains linked to two trends, as explained Eloi, expansion of existing district networks while decarbonizing them, as well as development of greenfield efficient district heating. Of course, this decarbonization roadmaps goes with investment into production assets, whether it is renewable or waste heat based, and often it is based on a merit order. First, waste heat from local infrastructure, urban industries, and then also local renewable resources like geothermal in the Paris Basin or sustainable biomass in specific regions. So those objectives remains our objective remains ambitious for France to double heat volumes from renewable and waste heat within 2030 and triple those volumes within 2035. And so the key drivers remain to support investments, like what we've got with the French Energy Agency heat funds, as well as regional funds. That we've got also the opportunities of white certificates, which support buildings DHC connections, waste heat recovery, or energy efficiency to buildings. And all those support schemes in France are defined for 3 years periods. The third period will start in 6 months and is currently under assessment. Those support schemes favor, of course, the most efficient system. And last but not least, we've got in France what we call DHC classification, which allows a city to define areas where it is compulsory to get connected to an efficient district heating or cooling, in case you've got some renewals of the system at building level.
Thanks a lot, Lorraine. Very impressive growth perspective. We will get back to the financing aspect. I think Eloi has already given us some hints how crucial the investment is to meet the expectations and the commitments. But I wanted to turn now to Olaf, zooming in onto the local perspective. Olaf, BEW is operating Western Europe's largest district heating system. And can you tell us a little bit more about the network and the perspective from Berlin?
Thank you, Pauline. Of course. Yeah, as you said, we are operating the Western Europe's largest district heating system. To be honest, we at least still split into two systems for historical reasons. As you recall, Berlin has been divided for decades in two parts, and district heating has developed differently in both parts, in the western and former western and former eastern part. So we are at least with our interconnected grid split also technically, which requires also some specific technology solutions. However, and together, or as in Germany, we are very much relying on cogeneration. Cogeneration is the basic source, so to speak, in Germany's district heating system. So it is in ours. You can see it here. The cogeneration share in heat generation is in Germany 86, in Berlin 82, and this is one part of two aspects of further development. First of all, the role of CHP and cogeneration will substantially change. Of course, in summertime, we don't need heat from cogeneration, in fact, and we don't need electricity from cogeneration. In fact, based in Germany, based on a huge extended generation capacities in wind and solar. However, the role of CHP will turn to deliver capacity rather than production in terms of system integration together with heat pumps, together with power to heat installations, together with heat buffers. We call it smart CHP systems in order to interact with the electricity system in the future. And this is one aspect. And the other aspect is how to replace the necessary heat generation by the climate neutral and by the renewable based concepts. We are doing so, and we have been starting roughly 1 decade ago. The first big step in Berlin, just to start with, was the decommissioning of a lignite CHP, which reduced by 2020, earlier than planned, by the way, by this, of course, substantial reducing the contribution of our company to the Berlin CO2 emissions. But now we are facing, and you have seen also the figures from Germany. You can see this decade, the current decade, is to implement and to start the necessary investments so that we are able to fulfill the decarbonization path in the next decade in particular. You know, Germany has for its own defined climate neutrality climate neutrality by 2045 compared to 2050 in the EU. So also we have to contribute in a way, but I think we will come back to this later in the discussion. Thank you, Pauline.
Exactly, Olaf. We will pick up on some of the points that you made. Very interesting perspective from a local operator. Now turning to Emanuele, Elwa mentioned that large heat pumps are rapidly developing in the sector. Your company is manufacturing heat pump. Can you tell us a little bit more from the perspective of Turboden, and as a heat pump manufacturer also, how do you see these trends in the market, and how ready your company is also to meet this increasing demand?
Sure. Good morning to everyone, and thank you, Pauline, for the great introduction and your question. First of all, let me briefly introduce Turboden company. Turboden is an Italian company active since 1980 in the field of energy transition, offering solutions for both power generation and heat electrification. We are part of Mitsubishi Heavy Industry Group since 2013, and the company basically provide advanced solutions based on proprietary turbo machinery with the aim to maximize the value of renewable resources and energy efficiency. At a glance, we are present across 50 countries with more than 450 plants, mainly organic Rankine cycle power plants for geothermal application, biomass application, waste to energy, and waste heat recovery from industries such as steel and cement, with the solution power only or combine heat and power, so to serve also district heating networks. Since 2019, we are active also in the large heat pumps arena, and as of today, we have basically two references. One is in a steel mill here in Italy, where we are exploiting waste heat from the electric arc furnace, basically from a water circuit to cool down electric arc furnace, and we tap that stream to deliver it to the district heating network. And this unit is online since 2023. Then we have another industrial reference case in the Northern Europe, where we are actually starting up today our plant. It is a combined solution made up of a isobutane large heat pump plus a steam compressor in order to cover a huge temperature lift from a cold heat source to the steam needed for the paper making process. And as I said, Turboden and MHI put a lot of focus on heat pumps development and established basically 3 different business units now in Turboden since 2023. So we do have our power generation that basically focus on our flagship product line, organic Rankine cycle system, heat electrification, so for large heat pumps and steam compressor development. And then we have a third business unit, which is the after sales department. It is worth it to mention that we are an Italian company. We are based in Italy. Our headquarters is in Italy. However, we are present also, for instance, in Germany with a local branch focused mainly on service activities, maintenance of our fleet in the country, as well as a subsidiary in Turkey for manufacturing, and some offices also in other places such as US. Let's say that we are excited about the market trends. We are seeing many district heating projects in the feasibility, planning, and tender stage. It is worth it to mention that there is the range of application of large heat pump is quite wide. So Turboden and the Mitsubishi Heavy Industry recognize the key role of large heat pumps not only in district heating but also in integration with industrial processes and also potentially with carbon capture and storage plants some years ago, and basically decided to massively invest on 3 areas. Resources, so we have established a dedicated team to optimize a thermodynamic solution, starting from our RC experience, but focusing more on heat pump solution. Technology, secondary technology, meaning we developed a proprietary turbo compressor, which is the heart of the large heat pumps plant. And thirdly, we are putting a lot of efforts also on standardization. Now we are focusing on to provide and design cost-effective products to serve the most mature markets, such as the district heating.
Very interesting. Thanks, Emanuele. I think it's very important to remind ourselves in at EU level we talk a lot about competitiveness and industry based in EU, and the heating and cooling and the district heating industry is mostly a EU a good success story, let's say so. I think that's very nice, and that makes us really much stronger in the whole energy security discussion. Also picking up on something you say, which is very interesting in terms of the diversification trend. We saw that there is a huge wasted potential. The sector is picking up on it. We see that now wasted is representing 4% of the mix, and it has grown 20%. So these are very encouraging trends. But of course, the potential is much larger. I think some studies are outlining 2,700 terawatts hour a year. So I wanted to perhaps turn to Lorraine. How critical do you see the role of wasted recovery for accelerating decarbonization? I think you already mentioned that in France this was a large trend. And can you illustrate perhaps with a project how what are the benefits and perhaps also the challenges of such projects?
Yes, of course. Yeah, wastage remains a critical and a priority in the merit order I have spoken previously to decarbonize district heating. This wastage remains local and would be lost otherwise. So we can speak about circular economy, and it should be mandatory to recover it. Indeed, what we can see is that lots of projects that were not developed 15 years ago are now being developed. So that's a good trend. And district heating could be seen as a hub aggregating local wasted sources. So maybe you can switch to the next slides. I will give a concrete example from Italy. And so waste still turns out to be larger than not only wasted from industry. You can find wasted from wastewater treatment plant or data center. It encompasses also sewage at building levels, urban infrastructure like hospitals, commercial center, and so on. So it's larger than only industries. But let me give you here an example from waste heat recovery in Italy. It's Lonato district heating. We have innovated with working with the customer or with the industry, Feralpi Group, and improving the process in order to be able to recover the heat. And by doing that, we have improved first energy efficiency at the level of the steel industry, which is great. And also we provide 85% decarbonized and competitive heat to the customers of the district heating. And I would say that the main barriers, but maybe we'll come back after more in details, it's the middle-term visions from industries in comparison to long-term visions needed for district heating. And for that, we hear that at EU level, we speak about some funds to support industrial waste heat recovery, so to cover the risk, and this is something we think it's important. Thank you.
Thanks, Lauren. Yeah, let's pick up as you said on the barriers. We see that there is this huge potential. We see that there are already a few projects. Emanuele, you mentioned another steel mill in Italy. But in your opinion, and I open the floor to the three of you, what are the barriers or the challenges that we need to overcome to actually tap into this huge potential? So I think Lauren started to hint at de-risking this kind of project when you have the wasted owner and the district heating who have two different time perspective that creates a little bit of uncertainty. Do you see other barriers or solutions and good practices that are in place on the market where you are active? I don't know who wants to jump in first. Just feel free to open your mic and contribute.
Maybe I can start. Directly connecting to what Lorraine has presented, it's very important to see the diversity of potential. For instance, in Berlin, Berlin doesn't have a traditional or a very large part of industry like in Hamburg, for instance, with a big aluminium mill. So the diversity of sources we can collect is pretty much larger. For instance, in Berlin, we are just investigating waste heat from so-called waste heat. I prefer excess heat because it is not to be wasted, honestly. Excess heat potential from data centers, and we are currently working or building a new or a replacement for a very old excess heat utilization installation on our site in Reuter. It's a very large site, currently primarily run by coal, and we want to replace coal by 2030 in our overall system. And at this point, we have the power plant. Next to our next neighbor is a waste incinerator from the municipal waste management company. And we have also the municipal water management company also in our neighborhood. And this is a very good example for common understanding and common working together. We have been using the heat or the steam, to be honest, from the waste incineration facility for many decades in an own turbine. And we are now replacing this turbine by a pretty much larger one in order to make use of this waste heat or excess heat further on. And next to this, we are installing 70 megawatts thermal heat pump, large-scale heat pump, to use the excess heat from sewage water. This is one of the opportunities we have. Next to this, we want to, or we use, of course, power to heat. We will, and we are looking forward, and this is not really a threat, but a necessity, that we need to use the broadest possible mix of sources, and we have, and these are differentiated from location to location. For instance, we are just starting to explore geothermal, which looks like successful, but we need to do it. But we need, for instance, the necessary financial backup in terms either of support or at least at some sort of de-risking instruments financially, because dwelling into the 4 kilometers downwards is not without any kind of risk, as you know. And it's the broadest mix, and turn it around. Any kind of regulation or picking or focusing on special technology and things like this, from the scale of molecules, hydrogen, other molecules, whatever, up to heat pumps, up to geothermal, it is a mix we need. And any kind of focusing, also regulatory-wise or supportive-wise, on specific technologies is more, in these terms, more a threat than a help.
Thanks, Olaf. Very clear, and also reflecting what's happening on the ground in terms of diversification. Very interesting to see how Berlin is going from coal to also partly recovering low temperature sources like sewage water with the intervention of the heat pump. Maybe turning to Emanuele or Lorraine, like in terms of exploiting this wasted potential from manufacturer perspective, like what do you see on the ground? What are the barriers?
So in principle, at least our approach is to try to find a solution in any case where possible. So regardless the type of its sources or the temperature required by the district heating network, we try to find a solution which sometimes is too much customized, sometimes is not that efficient because of physics. However, I don't see really limits, but more when the solution is suitable for the business plan of the operator. It means that it is needed also to support suppliers to develop and to allocate resources to develop appropriate solution as the market requires. In principle, large heat pumps could also accompany operators in the journey toward the make network more efficient, so decreasing the temperature. Maybe it's not always possible, but in principle, heat pumps can vary the operating conditions, can be upgraded in the future, can be adapted in the future. So I don't see technical barriers, but more how suppliers are in the position now to invest on such a type of solution and optimize such type of solutions. Then on the secondly, I think all the discussion around the type of refrigerants could be an issue to enable, I would say, fast deployment of projects. So for the customer is important, for the end user is important to better understand what is the regulatory framework around the refrigerants in order to organize the permitting procedure accordingly. And in that case, also the supplier might react according to such context.
Very, very interesting. Yeah, it makes sense. Manufacturer needs visibility on the regulatory perspective. Nothing new there, but good to remind policymakers about it. I wanted to pick up on something you said, Lorraine, that is very interesting, which is the de-risking scheme. You mentioned that in France there are some interesting developments on insurance scheme with regards to waste heat. We know that there are some for renewables, but can you tell us a little bit what's going on? Because I think it's quite interesting to see how this would work in practice.
For the moment, it's not really implemented for waste heat. We've got white certificate and we don't know for the next period. But I would say we've got the experience of the geothermal public-private insurance scheme. That is a good example with the short-term and the long-term, meaning that in case the resource we find is not the quality expected, then there is a buffer. We can be insured, we can mitigate that risk on CapEx and then during operations. And so we think that it could be also interesting to have an kind of insurance scheme that could mitigate also waste heat risk we can take for to invest for district heating. And at least the first risk is if the producers, waste heat producers do not more exist. So this is the main topic.
Thanks a lot. Yeah, I think this is being discussed also at EU level. There are some hints in the Renewable Energy Directive to incentivize member states to put in place this kind of framework. So that is definitely something to further explore in the context of what the European Commission is preparing in terms of the revised heating and cooling strategy for early next year. I wanted to come back on another aspect of diversification that Emanuele and Olaf already hinted at, which is grid integration or system integration. We know that there is a huge challenge ahead with regards to volatility of electricity prices connected to increasing the capacity, which is of course positive. But the other positive news is that to mitigate this cost, avoid curtailments, stabilize grid, the district heating network has a huge role to play. namely through large-scale heat pumps. So maybe, Emanuele, if you could explain a little bit what roles can this kind of solution play in terms of providing more grid stability and helping also decarbonize the system as at the same time.
Sure. As everybody knows, let's say grid stability relies on maintaining a continuous balance between power generation and power demand, and any significant deviation can lead to a frequency and voltage instability, potentially resulting in blackouts. To accommodate these changes, grid codes evolves and allowing, let's say, a wider ranges for frequency and voltage, enabling remote control of active and reactive power and passing also micro interruption. And in such context, the electricity market now includes a balancing power market where producers and consumers can trade flexibility to help the grid to stabilize. On one end, battery storage might offer a chemical solution, but it comes with significant environmental impacts. There are also alternative storage systems under development, such as thermal energy storage, gravity energy storage, while enhanced grid integration with industrial and heating processes offer a cost-effective and rapid deployment path. In this context, large heat pumps can really play a key role. When integrated into district heating or buffered thermal system, they can provide fast response balancing power both up and down. Their thermal inertia allows to absorb and release energy quickly, supporting basically at the end of the day grid frequency regulation. To give you an example, and reflecting our reference plant in the steel mill to serve the local district heating network mentioned before in the introduction, it operates according to the steel mill production cycles with automatic start and stops. And in normal operation, the electric load adapts to the thermal power set point. Indeed, it could be possible to use the district heating high inertia as a heat storage and let the heat pump to consume the electric energy, controlled by basically the grid when necessary. And the reaction time allows to support the grid very quickly in a matter of seconds. So in other words, the heat pump can be seen in the other way around. Instead of designing the heat pump to provide a given thermal power output, it should work in a wider range of operation in order to absorb an amount of electric energy as needed by to help stabilize the electrical grid.
Thanks, Emanuele, for this very precise description. Maybe turning to Olaf, as you already mentioned, Berlin as a climate neutrality target by 2045. So, and for this, the heat pump and e-boilers, will have a quite a large role in the mix that you described. Can you tell us a little bit more, perhaps on how it works and what do you see as a challenge for the system, be it, I don't know, on the technical perspective, but also perhaps on regulatory perspective?
Mm-hmm. I can directly connect on to Emanuele, and with an integrated, as I described before, integrated cogeneration and smart cogeneration approach. Cogeneration, heat pump / power to heat installation, heat buffer. This is a element of flexibility in both directions. So in times where we have a huge amount of renewable based electricity in the electricity grid, power to heat pumps and the buffer can take this and can utilize this in a useful way, and this is a particular difference between electricity, as Emanuele described, and district heating. District heating can be stored over hours, partly also a longer time. it's for electricity still a problem. Batteries, we know, pump storages also, but it's a long way to go in this regard. On the other hand, in the other time frame where not enough renewable-based electricity is there, maybe in winter times when it's dark and no wind is blowing, CHP comes in and is providing necessary capacity as well as generation, and that means in turn. What we see to be developed further, and we are just discussing in Germany, or we're starting discussing in Germany, grid tariff structures. And we would underline that the behavior or the being there or being not there in times where peak load either is required or we have enough or more than enough. We call it grid-related behavior, and in times where we can behave grid-related and the grid supportive, we are talking about electricity grid, then we see a room for, or necessity room for reducing grid tariffs in both directions. If you are running your installation in peak time, this is very, very challenging for the electricity grid operator. And for instance, our Berlin grid operator is expecting, based on many factors, double to triple the peak load from roughly 2 gigawatts electric to 4 to 6. So that needs to expand the grid, of course, but it needs also to have flexibility options with us. And coming back to your question, how do we realize what are we doing? We do both. We are looking for further sector integration via gas/molecule-fired CHPs, waste heat utilization at large scale heat pumps, power to heat, biomass, deep geothermal we are going to explore. And on the other hand, we are relying and we are contributing to the expansion and further development of the relevant infrastructures. This is our own infrastructure in terms of district heating grid as well as storages. We make use of grid densification by connecting, increasing the share of houses where possible. We have also have an interest on the evolution of the gas infrastructure or molecule infrastructure in terms, for instance, for the shift to the hydrogen technology. And of course, we are relying to some extent, even though as described, we can support this, to the expansion of the power grid. As said before, it's a broad mix, and regulatory-wise, maybe one key barrier when we were talking about heat pumps. We have currently an intense debate on refrigerants. We call it, or it's familiar as PFAS discussion. PFAS discussion as such is okay, and the direction is okay. However, regulatory stability is needed. So to some extent, it should become clear what will be required by when, and everything which is currently underway needs to be at least have a suitable time for for running and for being replaced in a suitable time frame. Emmanuel is better than I'm able to describe how we can switch refrigerants from a PFAS base to a non-PFAS base and things like this. We don't want to go into details, but this is what is the result of regulatory instability is mostly in the terms of a company investment reluctancy, and investment reluctancy is nothing we neither from a company's perspective nor from a societal aspect we can deal with, because the time for implementation is now, the time for investment is now, because all this kind of transition, at least in the scale we are talking about, is nothing of years, but it's a matter of decades, and therefore we need to start now.
Thanks, Olaf. Very clear. Actually, picking up on the refrigerants, I see that we just have 5 minutes before the end, so maybe let's take some question. There's some interesting question in the Q&A. So I think it's for Emanuele. It's from 1032. If you open the box, what refrigerants are used in turbine and heat pumps? What are the range of capacity they can provide? Which are the working temperature between evaporator and condensator the heat pump can work with, and the COP related to this limit. So it's perhaps a little bit calling for very technical discussion, but if you could give a rough idea, like in a couple of sentences.
Yeah, coming from the RC experience, Turboden in principle has the widest range of portfolio in terms of working fluid adoption among HFO and hydrocarbons. We recognize the trend. So our heat pumps now for the design, we are based mainly on hydrocarbons. So butane, isobutane, normal butane, pentane, but for district heating is not suitable, and also propane. We can use very cold heat sources down to 0 degree of the seawater and provide heat up to 100. Well, there is no real upper limit, but with a single unit, we can achieve from 0 to 120 with a butane option. We can go also higher, not I think suitable for district heating application. The COP at the end of the day is always in the range of 50 to 65% of the COP of Carnot. It's always like that. So it's more at physics, limits imposed by physics. So we do have either more standard solution, but especially customized solution. So we don't have real limits. And the COP can also be optimized depending on the case and optimization criteria. So working with pinch points of the heat exchangers. But I can, of course, elaborate more in a dedicated session.
Thanks a lot. Yeah, I don't have the name of the person who has the question, unfortunately, so we cannot address that specifically. Maybe a very easy and quick question: how many households are connected to Berlin district heating network? If we have this data.
Yeah, we are supplying 700,000 flats at least. So this is 1/3 of the entire household, roughly 1/3 of the entire households in Berlin.
Okay.
Plus minus, and then you have flats. I think the average, if I'm not mistaken, the average is either 2 or 2.5 persons, and therefore households, flats, and so it's sometimes a little bit statistic, but roughly 1/3.
All right, very clear. We have a question that is quite long, but it's about. Okay, I will try to read it. Our new build developments typically connected to 4th generation low temperature district heating system, and is this becoming the standard approach? Are there incentive or regulatory requirements in place encouraging or mandating the decarbonization of gas use in buildings? Okay. And are new gas heating system installations still permitted in most countries, and are there plans at the EU or national level to introduce a ban in near future? So yeah, it's a little bit of a tiered approach. Maybe we can deal like with some aspects. I don't know who wants to jump in. Maybe on the 4th generation approach.
Maybe I could start with the building with gas and buildings.
Okay.
The basics are laid down by the European Energy Performance of Buildings Directive, the EPPD, as redrafted and recasted in the last Commission period and parliamentary period in 2024 in the end, and setting up the new standard of the so-called zero emissions building, which becomes the standard for new builds, but also for deep renovations in the future. By this, this is the European framework to, in the end, to phase out oil and gas individual heating systems, because a zero emission building is to be supplied either by renewables on site, or supplied by heating and cooling from efficient district heating cooling systems, so like ours, or what we are going to bring in, and to other. And by this, there is no individual gas and oil boiler in the future, and this is a path of renovation. And of course, member states can add on these requirements and need to design and implement the EPBD accordingly. And then it's up to the individual member state how the building code in the end allows it. And in Germany, gas is still one of the technologies you can use, but stepwise it will also be phased out.
Thank you. Don't know if Lorraine or Emanuele, you want to add?
Regarding the fourth generation district heating, I would say that, of course, the trend is to lower the temperature to improve efficiency of district heating. We have said that there are existing district heating. We've got also existing buildings, so we have adapted to what is possible. But even with very old buildings, we can decrease the temperature at 70 degrees C. And so we can go also below with the first generations, but it's easier when it's a greenfield projects where you design also the emitters to receive this very low temperature below 45 degrees C. So it's always on the table, and we have to study it and the level of temperature, which you can adapt thanks to heat pumps also, is based on the global system. We have to answer to demand. We can optimize at building level and at production level. But yes, it's always studied and deployed as efficient as we can in each district heating and cooling.
Thanks a lot. I see that we are running over time. I apologize because you did a great job in asking a lot of questions, but we can unfortunately not pick up on everything. Maybe I'd like to ask our speaker for, in order to conclude, for a super short round of conclusion, or one takeaway that our audience should go away with. I don't know. Eloi, would you like to start?
Yes, thank you, Pauline. Yeah, so well, I would refer to the data, which shows a growing and changing sector. This being said, I mean it's time to accelerate the heat transition to harvest the full potential. And well, as a concluding word, I would say that in this context, the work of the Commission to launch a new heating and cooling strategy will be a very important milestone. Maybe one thing about cooling. So I referred to district cooling in my presentation. Good public policies start with good data, and we need, I think, better data on cooling. So better data collected by member states in the comprehensive assessment, but also in the new EED, there is a provision by which cities will do some heating and cooling planning, and cities with more than 45,000 inhabitants. And I think it's very, very important in this context that they very seriously consider cooling demands. Voilà.
Thanks, Eloi. That was very synthetic. Thanks a lot. Olaf, one last word for takeaway.
Thank you very much. Coming from the regulatory and policy side, I would say we have a lot of good provisions from the Fit for 55 package. The EED paves the way for efficient district heating, so we know the steps. The EPBD, as shortly described, is also clarifying what to do in the future decades. Therefore, now it's time for implementation, as I said before. Now it's time for starting, for investing and for implementation, and that needs a stable, plannable regulatory framework, and in particular a flexible approach that we can tap into all the necessary resources we have, and with the broadest possible mix. So time for acting is now, and surroundings and framework should support this. Thank you.
Okay, thanks, Olaf. So we have data, time for implementation, and stable framework. Lorraine, what would be your recommendation takeaway?
Yes, I would say that there is a need. It's time to put money on the table for project and resources and systemic approach for that are good for cities like district heating and district cooling. And we should avoid stop and go with support schemes. We need visibility, stability. It has been said before. So provide certainty and adequate level of funding. That's it.
Thank you, Lorraine. And Emanuele, the last word. We can't hear you somehow. No.
Now? What about now?
Yes. Now,
Okay, sorry
okay.
for that. So electrification path is very clear. Large heat pumps will have a key role in the transition. I think everybody agrees. And Europe now has the technology. So I think we really need an industrial policy dedicated to manufacturing that reflects this in order to create core and unique competencies in the continent.
Thanks a lot. Yesterday, indeed, the state aid for clean industrial policy was published. So we're hoping that the investment will also pick up. But we are slightly over time. So I would like to thank the speakers for contributing today and showing us the best practice and making recommendation and I would like also to thank our sponsor, so BW, Engie, Kamstrup, and Turboden, for their support. And see you next year for the Market Outlook 2026. Have a good day.